let arctan x be the inverse function of tanh x. Write down the domain and range of arctan x and find a formula for arctan x. Well, I'll start by trying to understand the problem. My problem appears to be about arctan x, but it looks like I don't have to worry about having to know what arctan x is already, because I'm told in the question what arctan x is. It's the inverse function of tanh x. So if I know about tanh x, I should be able to do the problem. So let me find out about tanh x first, and then I should be able to do it. So tanh x is, here it is, it's sin x over cos x. Well, that kind of makes sense. Tan x is sin x over cos x. Sin x is e to the x minus e to the minus x over 2. And cos x is e to the x plus e to the minus x over 2. And so when I actually do that division, the over 2's are going to cancel, and so I'm just going to be left with e to the x minus e to the minus x over e to the x plus e to the minus x. So that's tanh x. Okay, so what does my question ask me to do? It says to find the domain and range of arctan x. Well, if arctan is the inverse of tanh, as long as tanh is 1 to 1, then the domain and range of arctan will be the range and domain of tanh. So if I can find the domain and range of tanh first, then I'll be able to do the actual problem I want afterwards. So let's find the domain and range of tanh. Well, the domain of tanh would be the set of all the values of x I'm allowed to put into the function. So the ones where the function is still defined. So let's have a look. Well, I can put whatever I want into e to the x, and whatever I want into e to the minus x, so that's okay. The only other issue would be if the bottom was 0. Now, e to the x and e to the minus x can actually never be 0, and they're added together, so the bottom's never 0 either. So I'm okay, I can put whatever number I like into tanh, so the domain is the set of all real numbers. Okay, now for the range. Well, the range would be the set of all values that come out of my function. So I need to think about what I can produce by putting various x's into that formula. And what I've seen before is that you see what happens as x goes to infinity and what happens as x goes to minus infinity. First, let me check what happens when x is 0. Well, tanh of 0 is e to the 0 minus e to the minus 0, which is e to the 0 plus e to the 0. The top has e to the 0 minus e to the 0, so the whole thing comes out as 0. So I can make 0. Well, now I'll do what I was planning to do and see what happens as x goes to infinity and what happens as x goes to minus infinity. So, as x goes to infinity, let's have a look at what happens to my function. As x goes to infinity, that bit would also go to infinity. It would just get bigger and bigger, so that's not going to help me. So what about this? Oh yes, well as x goes to infinity, that would be e to the minus infinity, which would be 1 over e to the infinity. So that would be 1 over infinity, which would be 0. So this bit goes to 0, and this bit goes to 0. So I'm left with this bit, which is 1, because it's e to the x over e to the x. So let's write all that down. As x goes to infinity, e to the minus x goes to 0, so tanh x goes to 1. So I can get everything between 0, because I can make 0, and 1. I should ask myself, can I actually make 1? Well, to make 1, the top of that fraction would have to be the same as the bottom. This one has a minus in the middle, and this one has a plus in the middle. So I'm taking off a non-zero number and adding a non-zero number, so they can never actually be the same, so I can never get exactly 1. Now let's see what happens as x goes to minus infinity. As x goes to minus infinity, well, e to the minus x would go to e to the plus infinity, so e to the x would go to e to the minus infinity, which goes to 0. So let's have a look at what happens there. So this time it's the e to the x that goes to 0, and I'm left with this bit here, which is minus e to the minus x over e to the minus x, which is minus 1. So tanh x goes to minus 1. So I can get everything between 0 and minus 1 as well. So it appears I can make everything between minus 1 and 0 and everything between 0 and 1, but I can't make 1 and I can't make minus 1. So therefore, the range of tanh is from minus 1 to 1, not inclusive. I think I'd like to check that by graphing this function on my computer. Here's the program called Geogebra. Y equals tanh of x. Okay, so it looks like I can put any real number in. Yep, and it does go from minus 1 to 1. Excellent, I've got it right. Well, the inverse function of tanh would have the opposite. The domain of tanh would be the range of arctan, and the range of tanh would be the domain of arctan. So I can just write that down right now. So the domain of arctan would be the range of tanh, which was from minus 1 to 1, and the range of arctan would be the domain of tanh, which was the set of real numbers. So that part of the question is done. All I have to do now is actually find a formula for arctan. Alright, well, it'll be easiest to write it as y equals, so let me start there. Let y be equal to arctan x. So if I can do some manipulations and get y equals some nicer formula than just arctan x, then the problem will be done. So what manipulations can I do? Well, the only thing I know about arctan is it's the inverse of tanh, which means that tanh cancels it out. So if I do tanh of both sides, I can get rid of the arctan. Like that. And I do know what the formula for tanh is, so tanh of y would be e to the y minus e to the minus y over e to the y plus e to the minus y, which would be equal to x. So that looks a bit more promising. If I can solve that to get y equals, I should have a formula in terms of x, and that will be my formula for arctan. So what I want is to get all the y's on the one side, which I already have, but in a much better version than what we've got now. So what's annoying me at the moment is that I've got that e to the y plus e to the minus y on the bottom, so let me multiply everything by that, and that will get it off the bottom of my fraction. So e to the y minus e to the minus y is x times e to the y plus e to the minus y. Well, I suppose I could expand that out. Okay. Well, I could put all the e to the y's together and all the e to the minus y's together. That might help. So e to the y minus x e to the y is equal to e to the minus y plus x e to the minus y. And then I can pull the e to the y's out of this left-hand side. E to the y times 1 minus x is... well, I could do the same over here as well. E to the minus y is 1 plus x. So what am I going to do now? Well, I don't know right out what e to the minus y means. In previous problems when I've tried that, it's told me what to do. So on the next page, I'll write out 1 over e to the y. So I've got e to the y times 1 minus x is equal to 1 over e to the y times 1 plus x. And to get rid of the e to the y on the bottom, I'd multiply both sides by e to the y. So I'll get e to the y squared, because there's two of them here now. 1 minus x is equal to 1 plus x. Doing well. To get rid of the 1 minus x on the left-hand side, I can divide both sides by 1 minus x. So e to the y squared is 1 plus x over 1 minus x. And let's see, when I do a power of a power, I multiply the powers, so this left-hand side is 2y, just there. And now I can do the ordinary thing I always do when I solve equations, is I can start from the furthest away from y. So I need to get rid of the e, therefore. To do that, I do ln of both sides. So ln e to the 2y, the ln and the e would cancel, and I'd get 2y. Ln of this other side, I'd get this, like that. And so now I can just divide by 2, and I get y is equal to a half of ln of 1 plus x over 1 minus x. Which isn't too bad a formula, I reckon, considering how bad tanh was to begin with. So have I actually finished the problem? I was supposed to give a formula for Arctan, and technically y is actually equal to Arctan, so I suppose I have finished, but just to make it absolutely clear that I really have finished, I can say, so a formula is Arctan x is equal to half of ln 1 plus x over 1 minus x. There's only one last thing I want to do, and I want to check if my answer is right. I'll go back and use Geogebra to just graph this function. So there's tanh x still. Let's do y equals a half times ln of 1 plus x divided by 1 minus x. That looks like the inverse. It looks like the reflection of tanh in the line y equals x, so it looks like I'm right. I wonder if Geogebra actually has Arctan in it. Well, traditionally most computers don't write arc, they just write a. So this would be Arctan if it was anything. Where is it? H of x equals a tanh x, so that's it there. Oh, it's been highlighted. That darker one is Arctan, which is the same as the function I had. So my graph is telling me that I'm right, so I'm happy to stop now. That really is the end of the problem.